Good morning or good evening, wherever you happen to be watching this. This is supplemental lecture number 4, corresponding to session number 2 of GIS for Geoscientists. This is going to be a relatively short supplemental video compared to the sort of foundation that I set with session 1. What we're going to be talking about here is a really seemingly straightforward topic that takes on kind of a life of its own when you conceive of a project to work on. And I should say, this video will make a lot more sense if you watch it after you see lecture number 2 or session number 2. If you watch this before, some of the context for why we're doing this search might not be immediately obvious. So you can watch it in whatever order, but I probably recommend lecture 2 and then watching this to kind of fill in the gaps. The topic that we are going to speak about today is finding data. So this, for a lot of our research, or if you're working a job, for our job description, a lot of the data that we're going to be working with that goes into GIS, we're going to gather ourselves or have a team gather that data for us. In such cases, finding data is not really that difficult because the data is sort of your quest. You're the one making the data. But a problem I outlined in session 1 that's rearing its head now as we actually start to work in QGIS is how do we actually determine the impact of these volcanic hazards at Guaguas Pichincha on the communities surrounding the volcano? This is a non-trivial question because it actually cuts to the heart of what it means to do GIS work and what it means to apply GIS to a natural hazards problem like this volcanic eruption. We obviously, being earth scientists, we have quite a good knowledge of the geology, and if you're a volcanologist, you may even have a good idea of the hazards associated with a particular volcanic eruption, including where those hazards are likely to crop up, how severe they're likely to be, the number of homes that could potentially be destroyed. You may, depending on your specialty, even have some knowledge available to you in setting out on this project on the earthquakes, the frequency and the magnitude of earthquakes, or on the chemistry of the gases being emitted, or potentially the chemistry of the streams that are running off the top of the volcano. All this information is what we're sort of trained to take in as geoscientists. Particularly here at Cambridge, this kind of geological focus is bread and butter. And it's really only once we start to get into these topics here that we kind of move outside of our comfort zone for many of us. And this is information that in some cases you may have an idea of where to find, but in other cases you may have no idea. Particularly if you are not Spanish speaking or you're not from Latin America, you may have no idea what the places to go are to get this kind of data. For instance, where are there major roads, airports, railroads, hospitals? That could be really useful if you're doing this project as a hazard assessment exercise. You would be asked to estimate, if you were working on this, the impact of an eruption on those actual physical built infrastructure. And therefore, you have to actually do an analysis, a GIS analysis, and produce a map that shows that impact in some cases. You also need really simple information that, again, you as a geoscientist may not be trained to find. Where are the municipal boundaries that actually define authority in responding to disasters? I can only speak from my experience in the United States and the UK, but a lot of these decisions about evacuations and how to deal with an impending natural hazard are decided at the local level, and different municipalities might make different decisions, and therefore you need to know where those are so you can alert the proper municipal authorities. And also there's an undercurrent here of not just the amount of people in the area, but the actual demographic breakdown. Is it mainly elderly people in the area? Do we have statistics on the number of people who are suffering from any other sort of like illness? Like, for instance, the hospital number I gave, we know we're living through a pandemic right now. Do we have up-to-date numbers on the number of people in a hospital? Is it primarily school children or young people living in the area? This affects a lot of the decisions that the decision makers are going to have to make. And you as the GIS analyst are the one who are giving them kind of the baseline information. You're not the one making the decision, obviously. You are the one who's providing them with everything they need to ensure they make the proper decision. And therefore, it falls on you to actually investigate these questions. What is the demographic breakdown of this area around the volcano? Where are small settlements? Where are the farmers? What is sort of the hydrological breakdown of the area? Where are the major watersheds? Where secondary lahars could take on a life of their own? And some of that connects to topography, which again, even if you're a geoscientist and you interact with topography a lot in your daily life, you may not actually have an awareness of where to find topographic data. So all to say, there's a huge gap in your knowledge potentially on how you're actually going to address the question that has been set you by your manager or by your organization. And so what I'm going to do for the rest of this video is highlight a few of these data sources. This is not going to be an exhaustive highlight. I'm sort of giving you a baseline to work off of. And beyond this course, I encourage you to bookmark all the links I suggest to you. And these are listed out in the PDF guide that accompanies session number 2. Bookmark those links and make sure that when you are confronted with a GIS problem, that those are your first places you check for the kind of data that you need. So for this problem, a data source, I'll call a clearinghouse sometimes, because that's just a term that I came across when I was in undergrad studying GIS, and I haven't really been able to shake that terminology. Clearinghouse just means, data source. You can sort of interchange those terms. A good clearinghouse for a lot of baseline municipal and even demographic data is this Geodata hosted at Tufts University in the US. There's actually a consortium of different North American universities that host this Geodata platform. And even though if you're not a Tufts University student, you can access the data sets and you can download them. One thing I'm going to highlight for today that's really critical, so make sure you underline this. You don't actually have to download any data from the original source to complete the exercise that I'm setting you. I provide you with all the data to make sure that everyone is on the same starting point. So if for whatever reason, I've only tested access to Geodata at Tufts in the UK and the US, I have no idea if in other countries it's not possible to access this data set from a particular ISP or what have you. Given that, I've provided in the accompanying data file for this session every single data set you're going to need to complete the course. So do not stress if you can't actually get access to this for the course, you're fine. Going forward, if you have trouble accessing some of these, hopefully you're able to find some alternatives. But again, I'm just trying to provide you with a baseline here. And I'm highlighting these data sources to make sure you know how to access them properly, even though you don't need to for this course. So Geodata at Tufts has a lot of baseline, mainly vector data sets that we can use to define municipal boundaries. And we will also actually use Geodata at Tufts records of sort of the data that they've pulled from the Ecuadorian government, I believe with the permission of the Ecuadorian government, on population statistics. It's going to help us inform our hazard assessment. There are lots of other data sources out there though, and depending on what the research questions are, there could be many, many potential data sources you need. So I've listed a few of these here. The URLs, again, they're listed here, but they're also found in the PDF guide. So you don't have to copy these down if you're watching this video. You can find these in the PDF guide or Google this search string and this will come up. With that, I'm now going to open my internet browser and I'm going to just show you some of these sources and discuss a bit more about how you'd access data and the kinds of data sets you might find at some of the big ones. So the first data set to highlight is actually the data set that forms the core of this course, and that's the geological data on Guagua Pichincha. And what I've highlighted here is the actual PDF for the hazard map that we use as our input for a lot of these exercises. So I pulled up here, this is actually my, I'm logged into my ResearchGate profile here, but this is a publicly available poster that was made for a symposium on Andean geodynamics in 2019. You can see all the authors here. I want to make sure I fully credit them because obviously I'm not the one who made the original map. And you can go down in ResearchGate, you can download this file. And when you do, you're given an entire research poster, essentially. And what I've done for this course is I've clipped a bit of that poster, a map that has actual hazard assessments that they've done, and that is our input into the QGIS software. So you can have a play with that, and I would encourage you to read a bit about this volcano. I kind of run past the geology in an effort to focus on the GIS for this project. But obviously, before I designed these exercises, I took a lot of time reading about Guagua Pichincha and trying to work out, what the right place would be to set this exercise. And there's some really interesting volcanological aspects of Guagua Pichincha's eruptive dynamics and geologic history, as well as Guagua Pichincha's hazard assessment that these folks have already done. So in some ways, the exercise I'm asking you to do is replicating their work, but it's to show you, because they've already done it, we can focus on the actual GIS task rather than the geological questions that would muddy the waters a bit and distract us from what we're trying to do, which is learn GIS. So yeah, this is where we derive the actual hazard map from. So really important starting point. All right, next on the ticket is Geodata at Tufts. And when you first log in to this particular website, you're presented with this. So really simple kind of instructions. Enter information, zoom in using map location. Okay, that sounds good. So there's a few ways you can interact with this. And just for starters, let me just try by typing Ecuador. That comes up, hit search. And what comes up, you see there's 719 results. There are a lot of different data types, and you can actually manipulate this. So you can see you can sort the results by name, by originator, by date, by repository. And you see it gives you a rich amount of data. It tells you where these data sets are derived from. A lot of these are going to be from the Instituta Geografia, sorry, which is sort of like the national Ecuadorian geographic data set people. Not really artful way of describing it, but every nation, most nations have a sort of national body. Sometimes, it could be a body for natural resources, or sometimes it's a body for geographic or surveying information that usually hosts their GIS data sets that are publicly accessible. And they're usually made publicly accessible because they're taxpayer funded. There are going to be exceptions to this. There are going to be some countries that maybe don't publish those data sets openly, and in which case you may have to go to some of these other places. But what Geodata at Tufts is doing is they're pulling on these publicly available data sets and centralizing them in one location. So they're a bit out of date because there's a backlog that it takes. These aren't like 2021 updated necessarily. And we can actually verify when a particular data set was published by clicking on the metadata, the I here. And you notice, so this is level 1 administrative boundaries, provincias. Apologies for my pronunciation if that's not ideal. You can see that this file was created in 2012. And if I click view, it'll take a minute, and that's because my computer's doing a lot right now. But what's going to happen is you see, as I highlight over a particular layer in a blue bounding box, it tells me where that file, the spatial extent of that file. It also is going to tell me once it loads, it's actually going to show up as, let me put some red boundaries in there. When it loads, it's going to show the actual spatial extent of that layer. And once I'm happy with a layer, I'm still waiting for it to load because my computer is being difficult. But once I'm happy with that layer, I can click this under this cart icon here. I can click the plus button and it adds this layer to my cart. And what that means is I can then download any of the highlighted layers in my cart to my local computer. Sometimes when you do this, Geodata will ask you to put in a login. I've managed to get around that most times. So you don't usually have to worry about paying anything when it says cart. It's just a sort of a checkout procedure for lots of GIS data. So that's really it for now. I'm a bit sad that my internet connection is so slow that it's not loading, but that's fine. We don't really need to worry about that right now. The key is that I've now shown you how to interact with the different data sets and how to sort the different columns, how to view, how to check the metadata when it was published. and how to download. So now you know how to interact with Geodata at Tufts. Just something to note that past participants in this course have shared with me is that Geodata at Tufts doesn't necessarily have information for every country. I think I had someone who wanted to work actually somewhere else in Latin America, and there weren't data sets like there were for Ecuador. So in some ways, I've kind of picked the ideal location for some of these data sets. But that being said, you should still be able to find many of the data sets you need in this area. So just let me know. I'd be curious to know what countries are and aren't represented. All right, I want to close out of these to speed up my computer a bit. This is actually not, not where I wanted to be. There we go. Okay. So I've loaded in now to this Socioeconomic Data and Application Center hosted by NASA and Columbia University in New York. So this is a really this is actually a really interesting data source. You see, this is what I keep doing. I keep accidentally clicking on the NASA button rather than the CDAC button. So if you Google this search term or you click the link in the PDF guide, this is a really fantastic data set. Some of it's centered on the US, but a lot of these data sets are global. So all of you, wherever you are in the world, should be able to benefit from this. There's a lot of, more socially oriented data sets here. So for instance, you see there's a data set in a collection called Poverty Mapping that provides us with vector files summarized for each country, giving us subnational infant mortality rates. And actually by saying subnational, to me, let me just click on that. To me, that would suggest that this is broken down by boundary inputs, national and subnational data. Yeah, so it's not even at the country scale. They actually break it down to much smaller grid cells, providing us with a better idea of what this looks like. Yeah, so I mean, you see here, we actually have, for say, the country of Brazil, we actually have data in sort of northern parts of the country, differentiated from the whole nation, which is really, really quite fantastic when you look at it. So the point here is that this data source, the CDAC Center, has a lot of different data sets you can work off of. You could search those directly here. You could see, I could click, for instance, climate. Let's say I'm really interested in knowing about comparing whatever sort of hazard I'm investigating to food insecurity, because maybe that affects how we make decisions about how to deal with that hazard. We could also potentially think about freshwater availability. Like, these are really powerful data sets that a lot of people have worked, potentially spent their careers developing. Commercial crop production centered on West Africa, coastal vulnerability mapping. I mean, these are some really rich data sets that I would encourage you to investigate at your will. For us, I actually didn't use any of these data sets. I may have used one of these data sets for a later session, but for our initial exercise, I didn't actually use any of these, but these are for future GIS projects, incredibly powerful data sets that allow you to explore population dynamics and environmental impacts in much finer detail. You see, I mean, there's all sorts of really incredible data sets you can work off of here. And then there's things that are seemingly less socially relevant. For instance, a collection of global roads data sets. But if you can imagine, it's actually really important to know where roads are, particularly across different national boundaries. And if we click on this map area of CDAC, so you see what I just did, I sort of, once you click on a data set, you can sort of view an overall summary of it, including recommended citations and publications describing how the data set was made, which is great to have that metadata. You can then go to data download and actually, pick up on particular data sets. Notice that, for instance, with this data set with G-roads, you can download as a geodatabase or a shapefile. This becomes a point where ArcGIS or ArcMap and QGIS diverge. Unfortunately, I shouldn't say it's impossible, but I've had trouble loading geodatabases, which are an ArcGIS Esri product, in QGIS. You can do it, there are ways around it, but it would probably be easier to just download a shapefile. And even the shapefile, even though it's bigger, it's not substantially bigger. Most modern computers should be able to handle that. It's pretty remarkable to be able to get these data sets at such a resolution. And if we click, say, for instance, on let's look at Asia and look to see the data set. I mean, it might be hard to see on your screen, but on my screen here, I can see really fine detail on all the major roads that are crisscrossing Asia. That's pretty remarkable to be able to download that so easily and for free. With these NASA data sets, you often have to have an account, but those are free to create and free to maintain. The other NASA data set, the other NASA clearinghouse I want to highlight where you can get data sets is Earth data. You can get raster data off CDAC here. There are definitely raster data sets, but there are a lot of vector data sets here. Earth data, while it has vector data sets, primarily I've used for raster data. And so when you go to Earth data, I just did that very quickly. You'll have this big long page talking about all the different projects that Earth data and NASA work on. Open access for open science, it's good to see. When you mouse over data in the top and click on Earth data search, this brings you to a screen here where there's a lot of options. So you can easily get overwhelmed. What you can start with is say, let me see if I can, type in precipitation amount. That was the keyword I put in here. And once I put that in, of course, let's load this. You see my computer's being very slow today. I apologize for that. So I may not be able to showcase this as much as I want. Here we go. So I typed in precipitation, and then on this sidebar here, which you expand by clicking the bar, there's a data set gets loaded, GPM ground validation, multi-satellite precipitation analysis, iFloods, very long name. Let me add that. Let me see if I can add that to the map display. My computer's just not cooperating today. What you'll be able to do is search by keyword. You can also search by land area by highlighting with these tools here, search by spatial rectangle. You can draw these out. For instance, I'm interested in North Central Africa here. And let's get rid of my keyword. Let's, start over in some respects. Yeah, there we go. Okay, so let's search. Let's search in Morocco, Algeria. And then let's search SR2M. See what comes up. There we go. Okay. So now you see there are 56 matching collections, and once you have a collection you're happy with, oh boy, when you click on it, you see, and you actually expand that particular option, you have an option to start adding these or downloading all of these. You can also add these to particular projects, so you can actually start to explore the data sets on this web browser if you'd rather not download to your machine and then deal with them. I would recommend downloading potentially not all 474. If you need to do national scale imagery analysis, we're going to talk about that in lecture 4 or session 4. So I perhaps wouldn't recommend downloading all of these SRTMs if you're doing that level of analysis. But once you're happy with what you have, you can click download all. And what it'll prompt you with, my computer doesn't break, is a login. So this is what I recommended in the initial setup for this course. I told you create an Earth data login. This is what's going to let you actually access these data sets. So that is pretty much it for today. Apologies, my computer wasn't acting more appropriately. Sometimes you can't predict those things. But the key is that I've showed you where the websites are. I've talked through some of the uses for the different data sources and data clearinghouses and what kinds of data you might expect there. Earth data is great for a lot of the environmental raster data you might need, including topography as well as hydrology, atmospheric conditions, and there are some other sort of more social data sets as well as vector data sets. Whereas the, see the CDAC area as well. When you try to download the CDAC data set, it's going to take you to Earth data as well. And this is where you're going to get access to these vector data sets through CDAC. So once you create this Earth data account, you'll be able to download those two things. I've showed you Tufts, and I've showed you where we got the geology. Any questions, let me know, and thank you for your attention. Have a good day.